Thank you for downloading this podcast. We want to know your entrepreneur story and how we can offer the help that means business. Enter Entrepreneur SA with FNB on 702.co.za or capetalk.co.za.
Stand up for the law. Stand up for decency. Stand up for compassion. Stand up for respect. Stand up for your community. Stand up for your future. Stand up for South Africa. LeadSA.co.za.
The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Reedy Clubby.
Hello, Chris.
Morning.
Lovely to chat to you again. We've been having a debate about C-section versus natural birth. It's being implied that women are not being given a choice. The doctors just make a decision to give them a C-section without assessing whether it's necessary or not. Apart from the section of women who choose to go for a cesarean, under what circumstances should a doctor decide on a C-section?
It's really interesting that you've brought this up, actually, because this week, just a few days ago in Britain, we have an organisation called NICE, N-I-C-E, which is the National Institute for Clinical Excellence, and they changed their guidelines on caesarean sections this week. In the past, the bottom line was that people should try for a natural delivery, and that under certain circumstances, then they could have a caesarean if the doctors thought that it would be better for the outcome for the mother and the baby. Mm-hmm. That has been revised this week, and now they're sort of suggesting that perhaps women should just be able to request a caesarean section whenever and wherever they want one, because they're arguing that it may be safer. I think this is quite flawed, and it's created quite a big amount of strong feeling here in Britain, because lots of midwives are saying, you know, the caesarean rates are at 1 in 4 in some parts of the country, and in parts of America it's 1 in 3. And it's a bit like saying, let's look at the short term. If you were to take a person who'd literally just smoked a cigarette and ask if they had any negative outcomes from having just smoked a cigarette, you wouldn't find any, and you would conclude that smoking is entirely safe. If you do a caesarean and look immediately after you do it, sure, the outcomes are good. You have a healthy mother and a healthy baby. But if you look at the longer term, there may be other consequences. In fact, there are other consequences. And this is why people are a little bit worried. The fact is that a caesarean is major abdominal surgery for a woman. And this strongly compromises the woman's ability to do certain things after she's acutely had the surgery and for a period of time. And that can make caring for the baby more difficult. Being born the natural way is also good for the baby in terms of squeezing out the stuff that's in the chest, making sure the lungs are clear, but also giving the baby its first taste of life in the form of a mouthful of muck. And I mean that in the nicest possible way, because when babies come out the normal way, they pick up a cross-section of bacteria from the mum's body, and those bacteria line the baby's intestines and set up what will become the fingerprint intestinal flora for the rest of that baby's life, because there's 100 trillion bacteria in the intestine, and we're now only just beginning to realise that they do a very, very important job in keeping us healthy and protecting us from other infections and allergies for the rest of our lives. Now, if you compare the bugs that settle in a baby's gut when it's born via the normal route versus a baby born via caesarean section, there's a very dramatic difference, at least initially. And the bugs that babies pick up when they're born by caesarean are the kinds of things you find floating around in hospitals normally, versus the baby born the normal way has the things that should be there. Are there any consequences of that? Well, people have done follow-up studies now looking at large numbers of babies, and they find there is an elevated risk of diarrheal illnesses and allergies in babies born by caesarean compared with babies that are born the normal way. Now, that's not to say that you should say to everyone you have to have a baby by a normal delivery, because what we know is that we want to end up with a situation where you have a healthy mum and a healthy baby. But if just defaulting to a caesarean for convenience is what people start to do, they could actually be having a lifelong legacy effect on their own health, because the major abdominal surgery that the mum has could be linked to subsequent problems for her, because you can end up with things getting stuck together inside because of the surgery. You can also be condemning yourself to having another caesarean if you get pregnant again. And for the baby, there may be these other immunological and maybe lung consequences that we haven't actually followed up closely enough to know if they exist yet, but there is evidence to suggest that they may.
Very interesting indeed. We always return to this debate. I remember last year I brought in some experts just to delve into this, and it keeps coming up again and again. But Chris, let's talk about this key to combating old age. I'm sure a lot of people would be happy about that.
Oh, certainly. Yeah. There's a paper that's come out this week. It's in the journal Nature, and it's by researchers at the Mayo Clinic in America, Darren Baker and his colleagues. And what they have done is to publish an initial finding. I think this is actually going to be quite a landmark study, which has enabled them to show that they can dramatically slow down aging effects in mice. So what they've been doing is looking at what happens when cells get old. And when we have cells in our body getting old, they effectively stop dividing. Cells have programmed into them something called a Hayflick number. And this is where a cell can go through a certain number of divisions before it stops dividing anymore. And that's an intentional thing on the part of the cell, because if it carried on dividing and dividing and dividing forever, there's a danger that it could become cancerous. So cells have this programmed number of divisions that they can go through, and then they're not allowed to divide anymore, and they become what's called senescent. Now, you might think that they'll just sit there and mind their own business quietly, but unfortunately, they're very bad for the environment in which these senescent or old-aged cells live. They effectively squirt out lots of chemicals into the local environment, which can be harmful for the healthy tissue around them. And I suppose one analogy that was put to me is it's a bit like peeing in the village well. It poisons the water for everybody. All of the other cells that are trying to do a good job and are still healthy are being harmed by the senescent cells nearby. So what the researchers wondered was, well, can we get rid of these cells? And if we did, what would be the consequence? So what they do is they make a mouse with an accelerated aging phenotype. In other words, it's a mouse that ages faster than it would do normally. And that's just to make the experiments happen more conveniently quickly. And they engineer into these mice a special signal, because when cells become senescent and old, they turn on a marker in the cells called P16. This is the cellular handbrake that stops the cells dividing. So what they've done is to link to that marker a special sort of genetic switch, so that if they give a drug to the mouse at any time, a certain drug molecule, it flicks this switch, which then turns on a death program in the cell, causing the cells to commit suicide. So they have this system where they can, whenever they want to, tell all of the senescent cells in certain tissues to just kill themselves and effectively get rid of the problem. So they do some experiments on their mice and compare mice that they kill all these senescent cells at different times of the mouse lifetime with mice that don't have this happening to them. And what they find is that compared to the untreated mice, the ones that get rid of all their senescent cells have much less mass or weight loss as they get older, their muscles remain much stronger, and they don't get eye problems and cataracts compared with the controls. And so this suggests if we could find a way to get rid of these senescent cells in a healthy person, in a normal human person, then you'd end up with someone who would remain much healthier for much longer into old age. It's obviously early days, because it's not trivial to do this kind of work. We're not going to genetically engineer humans to make it possible anytime soon. But by unlocking the mechanism by which it happens, we're a step closer to not having to reach for the face cream quite so often.
Oh, wonderful. I look forward to that. I hope I stay alive long enough to see that happening. Let's go to Maya Fisher-French. Nice to talk to you from Hout Bay. Good morning.
Hi, Rudy. Yes, I have a question. I have an egg boiling machine that you put in anywhere from 1 to 7 eggs, and then you put the lid on and it steams them and cooks them. But it also it tells you how much water to put in depending on how many eggs you have in there. And the more eggs you have, the less water you put in, which seems counterintuitive. Why?
Nice.
Hi, Maya. I've been asked this before, and I don't know because I haven't got the gadget. But intuitively, what I think it might be is purely down to the attenuation or absorption of the microwaves, because water is very, very good at soaking up microwaves, but then so are eggs. And so the more eggs you put in, then the more microwave energy is going to be soaked up as it goes across the cooker and goes into each egg. Now, if you've only got 2 eggs in there, then there's going to be an enormous amount of microwave energy to share between the water and the 2 eggs. But if you fill it up with lots of eggs, then the same amount of energy has to now share out amongst all the eggs. So you don't want as much water, because otherwise you could be robbing the eggs of as much of the microwave energy that would go through and cook them as you could, as you would do otherwise. And I think that probably is what's going on. But I haven't actually got the gadget. So if you could maybe let me know the name of the gadget, I'm going to do a little bit more poking around, because someone else did ask me that question and I had to come up with a similar kind of speculative answer. And I'd really like to actually know.
I'll have to go check. I'll have to go to the kitchen and check.
Yeah,
I'll drop you an email. And
okay,
all
right.
That would be great. It's Chris.
So I don't know.
If you send it to chris@thenakedscientist.com, I'll pick it up with you later.
Okay, great.
Thank you so much.
Thanks, Maya. Great question.
All right, and let's go to, is it Jean in Randburg? Jean, I beg your pardon. Yes,
Hello.
Jean?
Hello, Chris.
Hello, Jean.
Hi. If one has which I have had, a hip replacement, can that leg be left shorter than the other? Because I have such discomfort. But, I had x-rays and they say that you can see nothing wrong. But I've got such discomfort, especially if I walk, a bit of an incline.
Mm-hmm. Yeah. Well, hip replacements do leave legs with a potential length disparity, because they have to carve away some bone in order to make room to put the prosthesis in, because you chop the top off the hip bone, the bit that plugs into the pelvis, and then ream out or drill out a hole down the inside of the bone to receive the prosthesis, which plugs down the inside, and then you plumb it into the pelvis. And when you do this, you do end up with a slight shortening of the leg. And what some people do is to compensate by building up a shoe, or sometimes having to do other things to make sure that the person isn't too asymmetrical, because otherwise you will have problems. But if you're having pain when walking around, there may actually be something else wrong, because sometimes these prostheses can loosen a little bit, and if they loosen, that becomes painful. Or if there's infection, then this can trigger loosening or other inflammation, and that too can become painful. If it's a new thing on a hip replacement you've had for a very long time, it could be just that it's getting worn, and you probably should get it investigated.
Okay, good luck to you, Jean. Chris, tell me about the story of the atmospheric filth that is hovering over Asia. I mean, we've had extreme weather, cyclones and all. What's that about?
Well, there's a group in America, in the University of California, San Diego, led by a researcher called V. Ramanathan. And he and his colleagues have been looking at this pollution that hovers over South Asia. There's something called an atmospheric brown cloud, an ABC, and this has been around for many, many years, in fact since the 1930s, and it's actually got 6 times thicker since the 1930s, and it's now 3 kilometres thick, and it's because of burning fossil fuels and burning off biomass on the ground and industry, and it's ejecting carbon material up into the air, and you end up with this big pall of smoke over the ground. And it absorbs energy from the sun. It actually makes the ground under this cloud 10% cooler than it should be. And so what this group wondered was, well, whether this could be having any effect on the cyclones, the big storms that come annually to this region. And so they looked at the weather data, and what they report in their paper in the journal Nature this week is that if you look at the storms around about the 1980s or so, they all had top wind speeds of about 85 kilometres per hour. If you look at the last 5 storms since the mid-90s, they've all had top wind speeds of 185 kilometres per hour. So a dramatic increase in intensity. And the amount of damage that they're doing is absolutely huge. There was a cyclone in 2007, which actually hit the United Arab Emirates and Iran and Oman, and that did something like $4 billion worth of damage, and there was enormous loss of life. So why are these storms increasing in intensity? And is it something to do with this big brown cloud that's now hovering over the area? Well, what they've done is to do some modelling and calculated what could be going on. And rather worryingly, it looks like this massive cloud is driving this weather systems to become much more powerful. Now, here's how it works. If you've got sunshine hitting the Arabian Sea and warming it up, you get lots of evaporation of saturated warm air off of the sea surface. And this rises and creates the updrafts that fuel the storm. But the Arabian Sea is at a higher temperature than the adjacent Indian Ocean, which means there's what's called a vertical wind shear. There's air coming in from the side, pushing the storm from the side. And the push that it gets at the top is different to the push it gets at the bottom. And this causes the storm, effectively the top, to break away from the bottom. And this makes the storm harder to form. But if you cut down the amount of sunlight hitting the Arabian Sea because of this brown cloud, now the temperature difference between the Indian Ocean and the Arabian Sea is lower, so there's less of this sideways wind push, this vertical wind shear. So as a result, the storm doesn't get pushed sideways and broken off, so it forms much more efficiently. And this means it can become much more intense. And as the researchers say themselves, storms that are more intense have a longer lifespan, so the probability that they're going to make landfall, in other words, hit the land and start doing damage, goes up.
Goes up, yeah. Okay, that makes sense. Let's go to Craig. Craig, you are calling us from Boksburg.
Morning, Chris. Morning, Rudy. Christmas beetles. Okay. You see them in November, December, maybe January. Where are they and in what form are they for the rest of the year?
Hello, Craig. I must confess I don't know what a Christmas beetle is, so tell me a bit more about those.
Little brown beetle that only comes out this time of year.
I'm really sorry, but I'm going to have to do my homework on them because I'm not acquainted with them. But there are some beetles which only come out every 13 or 17 years. There are lots of different species, and interestingly, they adopt prime numbers as their years for emergence. Most of these beetles live under the ground, and they're in the form of larvae. So they come out as a beetle, they find another beetle, mate with that beetle and lay eggs. The eggs hatch as larvae. The larvae exist underground and they eat various things including soil-dwelling nematodes and bacteria, fungi and other larvae, other things under the ground. And they can become really quite large as grubs underground, many of these beetles. And then at the right time of year and on the right time course, they then turn into a pupa. They then emerge from that as a mature beetle, which then burrows up to the surface, comes out, and then starts the life cycle again. And by using prime numbers like 13 years and 17 years that they emerge, this means that they're much less likely to fall into a pattern of other animals that might eat them, which go through yearly cycles, because it's much harder for those animals to reach very big peaks and then come in and eat all of the beetles. So it's a way of throwing into disarray the natural cycle of boom and bust of predator and prey. So that's their survival strategy.
Chris, we do call it the Christmas beetle, but I've just checked on the internet and it says that it's a name commonly applied to the Australian beetle, is it genus, Genus, and the name is Anoploghnaths. So that's its scientific name. And they are known as Christmas beetles because they are abundant in both urban and rural areas close to Christmas.
I wonder if it's because they're called Christmas beetles because Anoploghnaths is not easy to say.
That's why I spelt it out, because there's no way I was going to attempt that.
What I'll do is I'll try and find out a little bit more about it. But yes, these things that are seasonal do live in the ground and in cool places while they're a larva, like a big maggot. And then they turn into the beetle when they get to the right size.
Yeah, exactly.
And if they do it annually, it's basically a seasonal thing. But I will certainly look up a bit more about this one and either post the answer online or I'll come back next week with a bit of an update on it.
All right. Is it Tini in Centurion?
Yes, that's right.
Mm-hmm.
Hello, Reddy and Chris.
Hello, Tini.
My question that's bothering me a long time is that when you look up into the air and you look at all the planets and the stars, they're all round. It looks like when at creation, at the Big Bang, all the stars and planets were put in with like a big bag of marbles and just thrown into the air. Why are they all round?
Haha. Well, we obviously haven't been to any of the stars outside our own solar system, but we can look at our own sun and we can look at all the planets in our solar system and then other bodies like asteroids and that kind of thing. And this tells us an enormous amount about how these things form in the first place. What we understand about the formation of stars and planets is that they initially form from big balls of gas and dust. Something gives that ball of gas and dust a bit of a push or a nudge. In some cases it might be another star blowing itself up, which creates a shockwave which pushes the dust together suddenly. And as this dust and gas begins to come together, gravity takes over and starts to push it together. And so what you end up with is what's called a protostar. This is a big accumulating ball of gas which pulls in towards itself. And the easiest way that every particle can get as close to every other particle as possible in order to have the correct minimum surface area to volume ratio is in a spherical configuration. It's the same reason that raindrops, if they're a droplet on a surface, goes into a sphere, is because that's got as many particles as close to each other as possible, the best surface area to volume ratio. And so all these particles are pulling together under gravity, and there will be a protostar in the centre of this this forming system, and then round the outside is more gas and dust, which slowly, under gravity, accretes into what's called a protoplanetary disk. And in that disk, the planetesimals, mini-planets, begin to form by, again, things pulling together under gravity. And it's all down to the fact that you want to get the particles as close to each other as possible for the smallest given volume. And that's why they form these round shapes, because that's the most efficient and effective way to do it. And once something gets beyond a certain threshold size, it's got enough gravity pulling things together tightly enough that it adopts a nice round shape. If you look at smaller bodies like asteroids and failed planets, we have an asteroid belt which is between Mars and Jupiter, you will find bodies that are quite large, but they're irregularly shaped. And that's because they've never got big enough for gravity to begin to pull everything together tightly and also add bits where there were missing bits, if you see what I mean, to make a nice round shape. But given enough time and enough mass, then they would form a round shape. And that's why everything, wherever you look, is a nice round shape.
Chris, very quickly on this, I know that maybe we'll give it more time next week, but chemical mechanics of suntans, I thought we were supposed to discourage people from sun tanning, but we still want to know how it works.
Well, it's very important to understand how you get a suntan for the very simple reason that if we want to stop people getting things like skin cancer, then if we can find a way for people to tan safely or increase the amount of melanin, the protective pigment in the skin, then if we understand how melanin gets made in the first place and how cells turn it on, then we could endow people's cells with more protective melanin to start with. There's a lovely paper. It's been published this week, and what attracted me to this paper more than anything is that it's a paper about suntanning, skin darkening and melanin, and it's by researcher Nardine Wicks, who's at Brown University in America. And what they found is that the cells called melanocytes, which make melanin in the skin, they actually have the same chemical in them that your eyes use in order to enable you to see. And what these cells are doing, it turns out, is that they are sensitive to ultraviolet using a chemical called rhodopsin. The ultraviolet shines onto this rhodopsin molecule and triggers a chemical change in it, which then triggers the cells to produce a burst of calcium. And calcium inside cells is a very potent signal, and it turns on the genes that then make the cell make melanin. And this means that within an hour of seeing some ultraviolet light, these melanocytes are already making more melanin. We used to think, on the other hand, that you needed to have damage to the cells and damage to DNA by ultraviolet B to make cells get a suntan subsequently. It doesn't look like that's the case. You don't have to do any damage at all. There's a special biological pathway there to make it happen. And it might be possible to harness that into the future so that we have the ability to protect people more safely.
Lovely. Chris, we'll chat to you next week. Thanks again.
Thank you, Rudy. Have a great weekend,
Ta-ta.
everyone. Bye-bye.
Bye.